You know what's funny? Most people think physics is hard. They think you need to be some kind of genius to understand it. But that's baloney. The real problem is that nobody bothers to explain things properly. Richard Feynman knew this. And today I'm going to tell you about this guy, not just what he discovered, but how he thought. Because here's the thing, Feynman wasn't just a Nobel Prize-winning physicist. He was a safecracker, a bongo player, an artist, and maybe the greatest teacher who ever lived. And the best part, his way of thinking, the Feynman way, is something any of us can learn. So stick around, because in the next 20 minutes, I'm going to show you how Feynman looked at the world and how you can use his methods to understand pretty much anything. Let's start with a simple question. Feynman grew up in Far Rockaway, New York. His father wasn't a scientist. He was in the uniform business. But his father taught him something more valuable than any textbook ever could. They'd go for walks, and his father would say things like, "You see that bird?" In Italian, it's called a ciotto lapatita. In Chinese, it's chung ling. In Japanese, it's katano tekta. Now, you can know the name of that bird in every language in the world, and when you're done, you'll know absolutely nothing about the bird. You'll only know about people in different places and what they call the bird. You see what happened there. His father taught him the difference between knowing the name of something and understanding it. This became Feynman's obsession. Not memorizing, not impressing people with fancy words, but actually understanding how things work. When Feynman was at MIT, other students would come to him with problems. They'd say, "Feynman, how do you solve this differential equation?" And he'd look at it and say, "Well, what does it mean? What's it actually describing?" See, everyone else was learning formulas. Feynman was learning physics. And here's the crazy part. This made him faster at solving problems, not slower. Because when you understand what's really going on, the math almost does itself. So the first Feynman principle is this: don't fool yourself into thinking you understand something just because you know its name or you've memorized a formula. Ask yourself, can I explain this in simple words? Can I see what's really happening? If you can't, you don't understand it yet. And that's okay. That just means you get the pleasure of finding it out. Now, Feynman developed what we now call the Feynman Technique for learning, and it's brilliant in its simplicity. Here's how it works. Step 1, choose a concept you want to understand. Let's say quantum mechanics, or photosynthesis, or how a car engine works. Doesn't matter. Step 20, pretend you're teaching it to a 12-year-old. Write it out or say it out loud. Use simple language. No jargon, no hiding behind complicated words. And here's where the magic happens. When you try to explain something simply, you immediately discover the gaps in your understanding. You'll get to a point where you say, well, it works because of the thing. That's the gap. That's what you don't understand yet. Step 3, go back to the source material and fill in those gaps. Study only the parts you couldn't explain. Don't waste time on what you already know. Step 4, simplify and use analogies. This is where Feynman was a master. He'd say things like atoms are like tiny solar systems, knowing full well that's not exactly right, but it gives you a picture to start with. You know what Feynman once said? He said, if you can't explain something to a first-year student, you don't really understand it yourself. And he meant it. He gave these famous lectures at Caltech where he explained incredibly complex physics using nothing but freshman-level math. People thought it was impossible. He did it anyway. So here's your challenge. Take something you think you understand, maybe something from your job, your studies, whatever, and try to explain it to an imaginary 12-year-old. I guarantee you'll be surprised by what you discover. Now here's something interesting about Feynman. He loved being uncertain. Most people hate saying, I don't know. It feels like failure. But Feynman, he thought uncertainty was beautiful. There's this famous story. A student once asked him, Dr. Feynman, why do magnets repel each other? And Feynman starts to answer, then stops himself. He thinks for a moment and says, you know what? I can't give you a good answer to that. I could say it's because of magnetic fields, but then you'd ask why magnetic fields do that. And I'd say because of quantum mechanics. And you'd ask why quantum mechanics works that way. And eventually I'd get to a point where I'd just have to say, that's the way nature is. He wasn't being evasive. He was being honest about the limits of human knowledge. See, bad teachers pretend they know everything. Good teachers admit what they don't know. Great teachers like Feynman help you see that not knowing is where all the interesting questions lie. Feynman worked on the atomic bomb during World War II, the Manhattan Project. After the bomb was dropped on Hiroshima and Nagasaki, he went through a period of depression. He said he'd lost his social irresponsibility, his ability to just play with physics for the joy of it. But you know how he got it back. He started watching a student throw a plate in the cafeteria. The plate was wobbling and spinning, and Feynman thought, I wonder what the relationship is between the wobble and the spin. So he worked it out, just for fun. No practical application, just curiosity. That playful calculation eventually led to work that won him the Nobel Prize. The lesson: don't be afraid to say, I don't know. Don't be afraid to be uncertain. That's not weakness. That's the starting point of all real understanding. As Feynman said, I'd rather have questions I can't answer than answers I can't question. Okay, here's something wild about how Feynman's brain worked. He thought in pictures. Most physicists at the time were working with incredibly complicated mathematical equations. Pages and pages of algebra. And Feynman looked at this and thought, there's got to be a better way. So he invented what we now call Feynman diagrams. These are little drawings, they look almost like doodles, that show what particles are doing when they interact. Instead of writing out horrible equations, you draw a picture. An electron goes here, a photon goes there, they meet, something happens. Simple. And here's the crazy thing, these little diagrams were so useful that now every physicist uses them. They're in every textbook. They're fundamental to how we understand particle physics. Why? Because humans are visual creatures? We're much better at understanding pictures than abstract symbols. Feynman applied this to everything. When he was trying to understand something, he'd create a mental picture of it. Sometimes a literal picture, sometimes a metaphor or analogy. He'd imagine atoms as tiny balls bouncing around. He'd imagine light as little arrows spinning. He'd imagine space, time as a rubber sheet that gets bent by heavy objects. Were these pictures exactly right? No, of course not. Reality is more complicated than any picture can show. But here's what Feynman understood: a good picture gets you 90% of the way there. And 90% understanding is infinitely better than 0% understanding with perfectly accurate equations you can't make sense of. So when you're trying to learn something difficult, ask yourself, what would this look like if I drew it? Can I make a mental movie of this process? Can I visualize it? If you can see it, you can understand it. Let me tell you about Feynman's other hobbies. He played the bongos. Not just casually, he played in a ballet. He drew nude models and sold his artwork under a pseudonym. He learned to crack safes and then proceeded to crack all the safes containing atomic secrets at Los Alamos just to prove the security was terrible. Why am I telling you this? Because Feynman understood something crucial. Play is not the opposite of work. Play is how you do your best work. When Feynman was feeling burned out, he wouldn't force himself to sit at his desk and grind away. He'd play with something. He'd work on a problem that had no practical value. He'd learn something just because it was interesting. And somehow, almost magically, this play would lead to breakthroughs in his serious work. You know why? Because when you're playing, you're not afraid to fail. You're not worried about being wrong. You're just exploring, experimenting, trying things. And that's the state of mind where real creativity happens. Feynman said physics is like sex. Sure, it may give some practical results, but that's not why we do it. He meant that the joy of understanding, the pleasure of figuring things out, that's the real reward. Everything else is just a bonus. So here's my advice straight from the Feynman playbook. Don't just study what you're supposed to study. Don't just work on what's practical or useful. Spend time on things that fascinate you. Follow your curiosity. Play with ideas. Because you never know, that random thing you're curious about today might be the key to your biggest breakthrough tomorrow. And even if it's not, you'll have had a damn good time learning it. So let's recap what we've learned about the Feynman way of thinking. 1. Know the difference between knowing the name of something and actually understanding it. Don't fool yourself. 2. Use the Feynman technique. Explain things simply. Find the gaps in your knowledge. Fill them in. 3. Embrace uncertainty. I don't know isn't failure, it's the beginning of discovery. 4. Think in pictures. Visualize what's happening. Create mental models. 5. Play. Be curious. Explore things just because they're interesting. Richard Feynman died in 1988, but his way of thinking, his approach to learning and understanding is more relevant than ever. We live in a world that's incredibly complex. Technology, science, politics, economics, it's all complicated and getting more so every day. But Feynman showed us that complexity doesn't have to be intimidating. With the right approach, with curiosity, honesty, playfulness, and a willingness to really think, any of us can understand anything. You don't need to be a genius. You don't need a PhD. You just need to be willing to ask questions, admit what you don't know, and have the courage to find out. As Feynman himself said, study hard what interests you the most in the most undisciplined, irreverent, and original manner possible. So go out there and find something out. Not because you have to, not because it's on the test, but because the universe is fascinating and understanding even a tiny piece of it is one of the greatest pleasures life has to offer. Thanks for watching. Now go think like Feynman.